Welcome, everyone. Let's dive into this fascinating world of AI learning, where AI systems are designed to mimic human-like learning processes. Yep, kind of like our brains, but on a larger and faster scale.
Yeah, it's pretty impressive. So, we're talking about machine learning at its core, right? Where AI learns from data.
Exactly, and that's the heart of it, machine learning. AI improves its performance over time by detecting patterns in data, sort of like how we learn by experience.
Right on. And the real trick is ensuring that these systems can take what they learned and apply it to new and unseen data without overcooking on the details.
Absolutely, yep. And that's what they call generalization, the ability to perform well on new data, which is crucial because if an AI system just memorizes data, aka overfitting, it pretty much falls apart with something unfamiliar.
Yeah, that makes a lot of sense. So, it's like building a muscle memory that isn't too rigid, right?
Exactly. It's like you practice a sport, you learn the moves, but you need to adapt when the game changes. Now, let's dig into the types of machine learning. We've got supervised learning, unsupervised learning, reinforcement learning, and even semi supervised learning. hmm
Okay, so with supervised learning, you're saying the model learns using labeled data, sort of like having an answer key?
Right, exactly. In supervised learning, the model gets input output pairs. For example, predicting house prices based on features like square footage, location, and stuff, where a loss function measures error and the model tries to minimize it.
Yeah, like a teacher giving you immediate feedback when you do something wrong.
Absolutely. And then unsupervised learning kicks in when there are no labels at all. The algorithm finds hidden patterns, like grouping customers into segments using clustering, say, k-means, or, using dimensionality reduction techniques like PCA to simplify data.
That's pretty cool. So, unsupervised learning is like exploring a mystery, trying to find commonalities you didn't even know were there.
Right, it's like going on an adventure without a map. And then we have reinforcement learning, which is all about trial and error. The agent interacts with an environment, gets rewards or penalties, and learns to maximize long term rewards. Think about it like training a pet with treats, um, only for an AI.
I see. So, it's a bit like a video game where you get points for good moves and lose points for mistakes.
Exactly, yeah. And let's not forget semi supervised learning, which combines both labeled and unlabeled data. This method is super useful when you have just a little annotation available, but a lot of raw data, sort of the best of both worlds.
Just to clarify here, doesn't combining labeled and unlabeled data sometimes muddy the waters? I mean, if the unlabeled data is noisy, wouldn't that hurt performance?
That's a great point. It can, if not handled carefully. But by using proper techniques like consistency regularization and smart data sampling, you can actually leverage that unlabeled data to, you know, enhance learning efficiency. It's like adding secret sauce to a recipe, but done right, it just makes things better.
Fair enough, that makes sense. Moving on, data is the absolute heart of AI learning, isn't it?
Yes, exactly. High quality, diverse data sets are critical. If your data is biased or noisy, the entire system suffers. That's why data pre-processing and feature engineering are so critical. Just like, say, cleaning and prepping ingredients for a gourmet meal.
Right, you wouldn't want spoiled ingredients in a recipe. So clean data really drives better predictions.
Exactly. And now let's get into the algorithms that process all this data. We have everything from simple decision trees and support vector machines to complex neural networks that try to mimic layers of neurons in our brain. Each algorithm has its own strengths depending on the learning task.
Yeah, like choosing the right tool for a DIY project. If you use a hammer when you need a screwdriver, it's just not effective, right?
Absolutely right. And speaking of effectiveness, one of the major challenges we face is finding the sweet spot between overfitting and underfitting. Overfitting happens when the model learns the training data too well, including all its noise, while underfitting is when the model doesn't capture the underlying patterns at all.
Yeah, kind of like memorizing answers verbatim without really understanding the concepts versus just guessing randomly.
Exactly. And to combat these issues, Techniques like regularization, L1 and L2, as well as cross-validation, are used to ensure that the model generalizes well.
Makes sense. And when it comes to assessing the model, we have evaluation metrics like accuracy, precision, recall, and even the F1 score for classification tasks, right?
Yeah, plus for regression tasks, we often use mean squared error, MSE. It tells us the average squared difference between the predicted values and the actual values.
That's pretty neat. And what about deep learning? That's been all the rage, hasn't it?
Oh, definitely. Deep learning involves neural networks with multiple layers. Think layers upon layers of interconnected neurons. These models excel in complex tasks like image recognition and natural language processing. But of course, they need a lot of data and computational power, often leveraging GPUs.
So it's like building a skyscraper. A lot of support and power is needed to maintain its structure, right?
Yeah, that's a cool analogy. And as these models get more refined, techniques like transfer learning come into play. You can take a pre-trained model and fine-tune it for a different task, significantly reducing the amount of new data and time needed.
Right, it's like upgrading an already sleek engine for a new car model instead of building one from scratch.
Exactly, yeah. Now, one critical aspect we also need to cover is bias and fairness in AI. Since AI models learn from data, they can inherit biases present in the data, potentially leading to unfair or discriminatory outcomes.
That's a really important point. It's like if your training data is skewed, then your AI might make decisions that are unbalanced or even unethical.
Right, and to mitigate that, techniques like bias correction are used, along with ensuring that datasets are as diverse and representative as possible. But still, it's a challenging issue, one that really calls for careful ethical considerations.
I agree. And it's refreshing to see that even as we advance, there's a focus on fairness and ethics.
Absolutely. And speaking of challenges, aside from the data and bias issues, AI learning also faces hurdles like balancing model complexity with interpretability and handling privacy concerns. It's a dynamic field with plenty of moving parts.
Yeah, the more complex models get, the tougher it is to understand exactly how they're making decisions. That's where explainable AI or XAI comes in, right?
Exactly. Yep. XAI is all about making AI's decision processes more transparent so users can, trust the outcomes more. And looking towards the future, we expect AI models to become even more powerful and efficient while incorporating these ethical and explainability considerations.
Right, so we're looking at not just better AI, but also smarter, fairer AI that's truly integrated into everyday life, whether in business, healthcare, or even robotics.
That's absolutely it. And as research continues to push boundaries, we're moving towards a future where AI learning isn't just about raw power, but also about responsibility and transparency.
It's fascinating to see how all these pieces come together, from the nuts and bolts of supervised, unsupervised, and reinforcement learning to deep learning, transfer learning, and beyond.
Yeah, it's a continuously evolving landscape. And every breakthrough pushes us closer to building systems that can truly adapt and learn like we do, even though the journey is filled with challenges such as overfitting, data quality issues, and ensuring fairness.
Totally. And while some might argue that the complexities could slow down progress, I think the ongoing research and ethical drives are really the catalysts for innovation.
I agree, though I sometimes wonder if a little too much focus on ethics might stifle the rapid prototyping of new models. But then again, without addressing those concerns, we risk perpetuating harmful biases, right?
Exactly, it's a delicate balance. And it's essential that we keep challenging our approaches while advancing the technology, ensuring that we don't lose sight of um, the impact on society.
Absolutely. And so, as we wrap up, it's clear that understanding how AI learns, from data ingestion through various learning paradigms to overcoming challenges like overfitting and bias, is crucial for building effective, innovative systems.
Right. It shows that the future of AI is not just about raw computational power, but about smart, ethical, and explainable progress. I mean, it's a whole new era of technology, isn't it?
For sure. And as we continue to explore this realm, We can expect groundbreaking developments that will transform everyday life, all while ensuring transparency and fairness. It's both exciting and challenging in equal measure.
Well said. Thanks for taking us on this journey through the intricacies of AI learning. It really makes you appreciate all the layers behind these intelligent systems, literally and figuratively.
Absolutely. And thanks for all the engaging insights and thoughtful questions along the way. Here's to the future of AI learning and to making it as effective and fair as possible.
Cheers to that!